Well, hello there. I'm the Doctor. If you know me, then you know that I travel throughout space and time, but that isn't the point right now. Right now, I'm here to answer a question that's been befuddling you humans for a while now. The question is there life in the universe outside of your world? Well, let's go. Well, this is your home world, Earth. Obviously isn't Mars or anything, but what a better place to start? With the characteristics of your planet. But where to begin with this, I don't know. I can't think. I'm so thirsty. That's it! Water. I'll be right back. Where is it? Water. Okay, well, Earth is called. Here's my mini model of Earth that I keep in my pocket. This is Earth. It's called the blue planet for one main reason. It's covered in water. A fresh source of water, completely clean for you to drink. And humans, their body is taken up by 75% of water. So you guys need this to sustain life. Also, it covers more than 70% of your world, so it's a major part of your lives. And within being outside with all the water and stuff, it's good to have some fresh air, which moves on to the atmosphere. You see the tiny clouds on here? These tiny clouds are in your atmosphere, which, just like the layers of your Earth, they're in layers too. Right now, we're in the troposphere. This is where you live. Now I could keep going on and on about this, but let me just put this in a nutshell. All the air that you're breathing right now is made up of the three major elements. Nitrogen, which takes up 78% of your atmosphere. Then there's argon, 1%. Oxygen, 21%. This is what we're breathing right now. And obviously in atmosphere, we're going to need protection. The sun is pretty hot. So in the stratosphere, there's the ozone layer. When light comes in, it bounces in, and it will keep on bouncing for a while, and then it will come back out. Easy. But then there's also the distance. Doesn't it look close? Look at the sun right now. Doesn't it look close right now? It isn't, actually. It's pretty far away. It's exactly 92.9 million miles. That's pretty far. But it's perfect for you guys and me. Because there's one major key to this. Your planet is close enough that it doesn't burn all day and freeze all night, but it isn't so far away that it will be freezing cold all the time. So you're pretty much in what we call the habitable zone. Well, right now, you've got to keep moving. Lots more to see, lots more stuff to learn about how life on planets, so let's go.
As old as forever, the fast in his prime, saw his blue spaceship materialize. He looked out.
Welcome to the sun. Why are we here? Because we need to explain two requirements for life on other planets. One of them, which I'll explain to you right now, is the Big Bang. The Big Bang is what happened when everything in the universe was just packed in together, and then it exploded and sent things all the way around the entire universe, making it expand and retract. And our universe is believed to be 13.5 billion years old. So in between that time, there needs to be enough time for a star like our sun to form. The sun is pretty huge, and it still isn't as big as most stars are. blue. There are even different types of stars. This is an orange star. And larger ones like blue stars use up much of their energy more fast and will die off sooner. But anyway, let's go back to Earth. It's getting really hot. Okay. Well, we're back from the sun, and my, it was hot up there. But we need to move on to the elements. The elements of Earth, which are for a planet that is like Earth for humans to live on, they need to be just right. The right amounts of nitrogen, oxygen, and argon to create the air to breathe, and the hydrogen and oxygen to create the water. Now, come on, we need to keep moving. Well, we're back in space, and we were talking about distance of the planets a while ago. And as you can see right here, here's Earth, 92.9 million miles away from the sun. But look at all the other planets. Like, here's Mercury. Its surface temperature can reach 801 degrees Fahrenheit. Mars, which doesn't have canals nor the little green men. Venus, which is called Earth's sister planet. Jupiter, which the great red spot, as you can see right there, is a 400-year-old storm. Saturn. Its distinctive rings are made mostly of ice particles. Uranus, which it spins on a strange axis, often pointing at the sun. And Neptune, which has the strongest winds in the solar system. Here are all the dwarf planets located beyond the orbit of Neptune. They're not considered planets of your solar system anymore. But think about it. Look at Venus and Mars. They're both pretty close to Earth. You guys believe that they once sustained life until you've sent probes or either rovers. Venus you thought was a planet until when you sent a probe down there past the clouds which were full of sulfur, which would make it rain, melting acidic water down into a volcanic world. Mars, for a long time you humans thought that it was habitable, that people lived on there. And when the book The War of the Worlds was put out on radio in the 1930s, people actually thought it was happening. But then, when scientists from NASA sent up a rover, this is what they saw. Welcome to the National Aeronautics and Space Administration, or NASA. This office, we are here to talk about life on one of Saturn's moons. This moon, Titan, which is the second largest moon in your solar system, as I said before, it has one of the most densest atmospheres. And scientists have noticed that hydrogen, which is in its very dense atmosphere, when it goes down, it sort of disappears without a trace. And well, what could happen to it? Because hydrogen can't just disappear. They have thought of primitive methane-based life forms because Titan, which has small bodies of water lakes made of liquid methane, they believe that these life forms are methane-based. It's only an assumption about it, but this could actually lead on that if people from Earth go to Titan and they find it, and that means that there'd be more than just humans out in the universe.
Go.
On NASA's other studies, they have their telescope, Washington AP, which is a planet hunting telescope, discovered 2 planets that were circling the same star, a red dwarf, and were similarly close to each other, just like Earth is to Mars. While similarly, Earth-sized planets weren't in the right place near their stars. Sometimes they'd be too far away, sometimes they'd be too close. This is very different in this so-called Goldilocks game for looking for other planets like yours that can support life. The 2 discoveries, one called Kepler-62e and Kepler-62f, are just right. They are pretty much fraternal twins. They are pretty different than each other. One is that Kepler-62f is large and mountainous, whereas Kepler-62e is more, balmy and watery. You'd say that Kepler-62e is like a Hawaiian sort of planet, and Kepler-62f is sort of Alaskan. And this pair is 1,200 light years away, and a light year is almost 6 trillion miles. Well, in conclusion, if there is life outside of your world, then we have to remember what we were talking about throughout this video. 1, we need a sun. Most importantly, a yellow or orange one, because those last longer than blue or reds. Then we need a planet that's not too far away, that would freeze all the time, and not one that's too close that would be burning hot during the day and freezing cold at night. Then we also need an atmosphere that can protect you from the harsh rays of the sun, and also to keep argon, oxygen, and nitrogen in the air for you to breathe. Then you need water, fresh water, and all the elements that you need to make it, like hydrogen, oxygen, and that's what it would need to be life-sustaining. And in a universe as big as ours, we have to think, if you're the only life out there, if there is any life out there, then the chances are pretty big. But we'll just have to wait and see.